Builder has pre-built models built by the Biointeractive team. And if you want any information about how to use Model Builder in your classroom, you can access the user guide and pedagogy guide here. For right now, let's start Model Builder. And you can see there's a host of models built by the Biointeractive team that you can use. There really are two types of models that you can make. There are these conceptual models and stock and flow models. The conceptual are really conceptual because they have neutral connectors, or causal models that have positive and negative connectors. What I want to focus on today are stock and flow models, and I'm going to use the carbon model to do that. So I'm going to open up this carbon model, and it's a self-check model. What that means is you will put objects into the workspace, and then you can check them to see how many mistakes there are. So there's one object mistake, 4 missing objects, 4 flow mistakes, and 1 missing connector. The main difference between a stock and flow model and a conceptual model is with a stock and flow model, there are object types, where in the conceptual models, there are just objects that you're linking with connectors. In this model, you have to name each of these objects as a specific object type before you can interconnect them. So let's take a look at what we can do here. You can look at the description box to kind of get some information about it. For example, you are going to complete the model, assign each object the correct object type, and then connect them to illustrate the flow of carbon between reservoirs. Let's take a look. So these are the object types. You have a stock, and what that is a reservoir. So this is what's going to accumulate in a system. Then variables are the objects that are modifying other variables or modifying flows. Variables can't modify stocks. The only thing that can modify a stock or increase or decrease a stock is a flow. And a flow you can think of as a drain pipe. So it has, in Model Builder, it has this little icon that looks like a valve. And this valve here can be regulated. It can be increased or decreased to cause more stuff to move in or more stuff to move out. With stock and flow modeling, you're really interested in the movement or flow of matter or energy through a given system, and there's going to be consistent units in that system. So let's take a look. So for example, if I were to say, hey, is this a variable, and check that, well, it's not. It's not a variable. And it's not nameless. These other objects are all nameless, so they're wrong too. So let's take a look at what else carbon in the atmosphere could be. Could it be a stock? And I'm going to turn the hints off for now to get them out of the way, and I'm going to minimize this box to get that out of the way. Okay, and I'm going to hit check. And we now know that it is a stock. So I'm going to move this carbon in the atmosphere over here. And carbon in the biosphere, I also think is a stock. So I'm going to check that. It turns yellow if you changed it and it needs rechecked. So I'm going to check that. And look, that's correct also. So now, how does carbon move from one stock to the other? Well, it's going to move with flows. Oh, I want to name that as a stock. Okay, so what could be a possible flow? Well, sunlight is not how it flows. Sunlight can increase or decrease a flow, but sunlight itself is not how it flows. One way it flows is by respiration. So respiration, I think, is a flow, and I'm going to check. And this is a little confusing. Let me turn that to a stock and check. Okay, you can see right now that there are 8 mistakes. which is correct. There are 8 object, hold on just a second. There are 3 object mistakes. Now, if I call this a flow and check, now there's only 2 object mistakes and my total mistakes went down. The reason you have red dots on here now is because the flow is connected in a particular way incorrectly. This flow is not connected correctly. So this is a valve on here, and it is going to be connected at one end or the other end. So where does carbon come from as it flows through this respiration pipe? Well, it's going to come from the biosphere. So I'm going to click on this, and it's going to flow from carbon in the biosphere. And now I'm going to check that. And now that is correct. And similarly, where does it go? Well, this end doesn't go out into an open system. That's what that infinity sign is standing for, is an open system. But we're going to say it's going to flow to carbon in the atmosphere. So I'm going to click on that, flow to here, and I'm going to change this so the arrow comes up nicely, hit check, and now that is linked correctly. So we have consistent units here. It's going carbon in the biosphere is just flowing to carbon in the atmosphere. And how is it flowing? It's flowing through this respiration flow. Okay, so now photosynthesis is also going to be a flow. And I'm going to link flow from, it's coming from the atmosphere, and it's flowing to the biosphere. So photosynthesis is how carbon is going from the atmosphere to the biosphere, and we have consistent units here. Hit check, and now all we have to do is name sunlight. Sunlight is not a flow because carbon isn't moving through sunlight, or sunlight, while it does increase photosynthesis, there's no carbon in sunlight. All it is a factor that is affecting how fast these flows move. Specifically in this model, it's how fast photosynthesis flows. Now, if I tried to hit the connectors, I can't because it has to be named an object type first. So what I'm going to do is I could say, well, is it a stock? No, not really. In this case, it is a variable because all it's doing is modifying. We're not worried about the accumulation of sunlight or the flow of sunlight. All we're saying is sunlight's modifying a flow. So let's check, and that's right. So one thing my students will often do is they'll drag the objects into this workspace, and they'll immediately name all the object types. And they can just check to make sure they're getting them right. Once they do that, now, what does sunlight affect? Well, sunlight affects photosynthesis in a positive way. What that means, again, is if we have sunlight and we have photosynthesis, as sunlight is low, photosynthesis rate is going to be low, and as sunlight is high, our photosynthesis is going to be high, so it's a positive connector. So it's going to be positive. I'll draw that in blue. Okay, and now we can check, and now we have 0 mistakes. So this is our model, and let me just reiterate what's happening here is you have little bits of carbon here that are then moving through this pipe to this stock here, which then they move through this pipe, little bits of carbon, to here. Now this is a static model, so it is not able to be simulated, but this is a stock and flow model. And what causes this valve to move faster is sunlight. So the faster this, the faster little carbon particles are going to move from the atmosphere to the biosphere. And if there was something that could be modifying, for example, respiration here, like some variable, then that would regulate, it would increase how fast carbon moves from the biosphere to the atmosphere. So really what we have in stock and flow models is you have, while these are connected from the biosphere to the atmosphere, they're connected by stuff flowing. And this is connected, but it's connected by stuff flowing. So it's a little different than just cause and effect relationships. We're really looking at the physical movement of stuff through a system. And that physical stuff is moving from one stock to another. And the only way stocks can be modified is with flows. Variables can only alter other variables or flows. Okay, I hope you found this model useful.